Hello everyone, welcome to new class. Today's class is about Norton's theorem. So, this is the fourth theorem in the network theorems. So, what is Norton's theorem? Norton's theorem states that any two-terminal linear network with voltage sources, current sources, resistances and open circuit terminals can be replaced by a single current source in parallel with a single resistance, where the value of the current source is equal to the current passing through the short circuited output terminals and the value of resistance is equal to the resistance seen into the output terminals. So this is the statement of Norton's theorem, and there are some procedures for doing the or for applying the Norton's theorem. So let us study about the procedures in the Norton's theorem. So next is the procedures or the steps for applying the Norton's theorem. First one is short the load terminals and find short circuit current ISC flowing through the short circuited load terminals using conventional network analysis. Second one is remove the load resistor and find the internal resistance of the source network by deactivating the constant sources. That is, for voltage source short circuit and for current source open circuit. And this internal resistance, that is the Norton's equivalent resistance, is denoted by RINT, that is R internal or RN. Third step is Norton's equivalent circuit is drawn by keeping R internal in parallel to the ISC. Then fourth step, reconnect the load resistor across the load terminals and find the load current IL. So these are the steps for applying the Norton's theorem. In the first step, short the load terminals and find ISC. Then in the second step, we have to find the internal resistance or Norton's equivalent resistance. Then third step, we have to draw the Norton's equivalent circuit, that is ISC in parallel with R internal. Then finally reconnect the load resistor and find the value of current IL. So the value of current IL is equal to the total current ISC into the resistance through the other branch, that is R internal, divided by total resistance, that is R internal plus RL. That is the current division rule. So this is about the Norton's theorem. Let us do more problems related to this Norton's theorem. Let us do a problem. Determine the voltage across 200 ohm resistor using Norton's theorem. So this is the given network. So here we have to find the voltage across this 200 ohm resistor using Norton's theorem. So in the first step, we have to find ISC. So to find ISC, that is the short circuit current, we have to short circuit that load resistor. So here that is 200 ohm resistor. So first of all, short circuit that resistor. That is, this is 200 ohm resistor. So short circuit it. Then draw the circuit again. So this is 10 volt, 50 ohm. Then this is 20 ohm, 1 ampere. And we have to find ISC. So this current we have to find. And here there is one voltage source and a resistor. So here the current will be flowing in this direction, and here this current source direction is in this way. So the sum of these two currents will be flowing through this branch. So we can write ISC is equal to, so what is this current? It is V divided by 50. That is 10 divided by 50 is flowing through this branch or this circuit. So that is 1 by 5 and that is 0.2. So 0.2 ampere is flowing in this direction. Then plus, what is the value of this current? It is 1. So 1 ampere is flowing in this direction. So the sum of these two currents will be equal to ISC. That is 1.2 ampere is flowing through this short circuited branch. Next we have to find, so in the step 2 we have to find R internal. R internal. So to find R internal we have to deactivate the sources. That is, here we have to short circuit this voltage source and also open the terminals. That is, here we have to open this branch, then open circuit the current source. So this is the circuit after deactivating the voltage source and current source, and also open circuit this branch. So here we have to find R internal. So what is R internal? So here R internal is equal to, here this resistor has no effect. So what is R internal? It is 50 ohm itself. So R internal is equal to 50 ohm. Then in the third step, we have to draw the equivalent Norton's circuit. So Norton's equivalent circuit. So here ISC is 1.2 ampere, that is 1.2 amperes in parallel with R internal, that is 50 ohm. Also redraw the or reconnect the load resistor, that is 200 ohm resistor. And here the question is to find the voltage across 200 ohm resistor. So for that we have to find IL or current through this 200 ohm resistor. So here IL is equal to, total current is 1.2 ampere, 1.2 into resistance through the other branch is 50 divided by 50 plus 200, and that is equal to 0.24 amperes. So IL is equal to 0.24 ampere, and the question is to find the voltage across this 200 ohm resistor. So V 200 is equal to IL into 200, and that is equal to 0.24 into 200, and that is 48 volt. So this is the voltage across this 200 ohm resistor. So in this way we are applying the Norton's theorem. Let us do another problem. Determine the voltage across 6 ohm resistor using Norton's theorem. So this is the given network. So first step is to find ISC, that is the short circuit current, or we can denote it with IN, that is the Norton's current. So to find ISC, we have to short circuit that load resistor. So redraw the circuit diagram. So it will be like this. So we have to short circuit the load resistor and find ISC. So this is 10 ohm and this is 5 ohm. This is 20 volt. So what is the value of ISC? That is the short circuit current here is, while short circuiting this branch, it will be like short circuiting this parallel branch also. So in effect, the circuit diagram will be like this. So this is ISC. So what is ISC? It is 20 divided by 5 and that is equal to 4 ampere. So ISC is 4 ampere. Now we have to find R internal or RN. So to find R internal, remove the load resistor and also deactivate the sources. So redraw the circuit diagram. So here this is voltage source. So we have to short circuit it. Then here there is a resistor. Here also resistor and here this one we have to remove the load resistor. So this is 10 ohm and this is 5 ohm. Then what is R internal? So R internal is equal to, these two resistors are in parallel. So we can write 5 into 10 divided by 5 plus 10, that is 15 and that is equal to 3.33 ohm. So R internal is equal to 3.33 ohm. In the next step, we can draw the Norton's equivalent circuit. So Norton's equivalent circuit is, here ISC is 4 ampere in parallel with R internal, that is 3.33 ohm. Then redraw the load resistor. So here load resistor is 6 ohm. And the question is to find the voltage across this 6 ohm resistor. So here we have to find this load current. So load current IL is equal to total current 4 into the resistance through the other branch divided by total resistance, that is 3.33 plus 6 and that is equal to 1.43 amperes. So IL is equal to 1.43 amperes. Then we can find the voltage across 6 ohm resistor and that is equal to IL into 6, that is 1.43 into 6 and that is equal to 8.58 volt. So voltage across the load resistor is 8.58 volt. So in this way we are applying the Norton's theorem. So in the next class we will discuss more problems related to Norton's theorem. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.